Hello everyone, it's Esperanza. Today I will be explaining to you some of the concepts and principles about the gyroscopic instruments. Any spinning object is considered to have gyro properties, and one example can be when a wheel and a rotor are set together to exercise these properties. They're called gyro instruments. Some of the most important characteristics of gyro instruments are great weight for their size or high density, and a rotation at high speed with low friction bearings. The reason why these characteristics are so important is because in the aircraft it's necessary that the gyro instruments remain stable with the change of altitude and pressure. That way we know that the information that is being displayed is more reliable. There are two general types of mountings, but the way they are set will depend on which gyro property wants to be utilized. The first one is called universal or freely mounting. This type of mounting allows the instrument to rotate freely based on its center of gravity. And the second type, it's called restricted or semi-rigidly mounted. In this type of mounting, one of the wheels or planes of freedom is attached in relation to the base of the gyro. There are two fundamental properties of gyroscopic action. One of them is rigidity in space. It refers to the principle in which the gyroscopic remains in its fixed position in the plane in which it is spinning. The gyro is mounted in a set of gimbal rings in which it is able to freely rotate in any direction, and if one of the gimbal rings is twisted or moved, the gyro it's going to remain in the wheel or plane in which it was originally rotating. The second gyroscopic action is precession, and it is a tilting or turning of a gyroscope in response to deflective force. The reaction of this force occurs at a 90-degree angle in the opposite direction on which the force was applied. This principle allows the gyro to determine a turn by sensing the amount of pressure created by a change in direction. Precession can create some kind of error in some of the instruments, and some others it might be necessary to create or to do some type of corrective alignment during the flight, such as in the heading indicator. The sources of power of the gyroscopic instruments are vacuum, pressure, and electricity. The vacuum and pressure sources provide power to the heading and the attitude indicator, and the turn coordinator is powered by electricity. The reason why there are two different types of power sources is to ensure that one of them is working or available when the other one, if the other one fails. And to avoid some type of errors in aircraft, it's important to monitor the vacuum pressure during the flight because the instruments may not be providing reliable information when the suction pressure is low. Aircraft use two type of turn indicator, which are the turn and slip indicator and the turn coordinator. The first one only shows the rate of turn in degrees per second, and the turn coordinator is mounted at an angle, so it initially shows low rate. In an aircraft, we also have the altitude indicator. It displays a picture of the altitude of the aircraft. In this instrument, the gyroscope is set on a horizontal plane, and it depends upon rigidity in space for its operation. Lastly, we have the heading indicator. It is a mechanical instrument designed to facilitate the use of the magnetic compass. Thank you for taking the time to watch my presentation. I hope it has helped you to better understand the concept of gyroscopic instruments.